and welcome to Friday's warm-up. Can you believe another week has gone? So we're going to warm up today with the percentage chains that you practiced yesterday. And we looked at the fact that if you can work out 10%, 50% and 1%, you can use those facts to work out all of the other percentages. Now you have a choice today. You can either, as your starting number, 100%, you can choose 360, or if you fancy a bit of a challenge, you can start with the number 126. Stop the video and see if you can find all of these percentages in the percentage chain. So what I'll do is I'll take off the 126 for a minute and we'll just look at the answers for 360. So half, 50% is 180. Halve it again for 25% is 90. I've then gone over to 10%, which would be 36. Double it to find 20%. Which is 72, and you could add those two together to get 30%. 10% and 20% would make 108. If we go back to the 20%, we can double it for 40%, which would be 144. And if we then go back to 10%, we halve it to find 5%, which is 18. Over to 1%, you need to divide by 100 for that, which would be 3.6. Double it to get 2%, which is 7.2. Up to 90%. So for 90%, we need to add 50% and 40%, or 10% times 9. 95%, 90% plus 5% would be 342. And 99%, you can do 100%, subtract 1%, would be 356.4. Now let's just have a look at the different percentages if you started with 126. So 50% would be 63. Halve it again to find 25% would be 31.5. 10% would be 12.6. 20% would be double that, 25.2. And 30% would be 10% and 20%. Double 40%. Sorry, double 20% to find 40%. And then I've gone over to 1%. Oh, I've missed out 5%. Half, 10% to get 5%. Over to 1%, 1.26, 2%, 2.52. 90% would be 10% times 9, 113.4, 95% is over here, 119.7, and 99%, 124.74. So we're doing a lot about shape this week, so I thought we'd have a bit of a 2D shape quiz during maths today. So what you will need is a pen and a pencil, and get ready to name the shapes. Is this an equilateral triangle, a parallelogram, or a scalene triangle? If you need to stop the video to write down the answer, please do. And of course this is an equilateral triangle. On to the next one. Is this a trapezium, a triangle or a heptagon. And this is a 7-sided shape, so it's a heptagon. On to the next one. Is this an equilateral triangle, an isosceles triangle, or a scalene triangle? Well, because this has adjacent sides the same length and 2 angles the same length at the bottom, this is an isosceles triangle. On to the next shape. Is this a parallelogram, a rhombus, or a rectangle? Well, we know it can't be a rectangle because it doesn't have 4 right angles. But it does have 2 pairs of parallel sides, 2 acute angles, 2 obtuse angles, so it is a parallelogram. Now, is this shape a rhombus, a trapezium, or a decagon? Well, I know a decagon has 10 sides, and a trapezium looks a bit like a trapeze. So this is in fact a rhombus. And how I know it's a rhombus is because it's a quadrilateral with 4 equal sides. The sides are the same length, but it's not a square. So, on to the next shape. Is this a rhombus, a trapezium, or a hexagon? And this looks like a bit like a trapeze. It is a trapezium, which is a quadrilateral, but it only has 1 pair of parallel sides. That's these here. And on to the next one. Is this a rhombus, a trapezium, or an octagon? And if you count the edges, you'll work out that this is an octagon because it has 8 sides. Is this a decagon, a pentagon, or a hexagon? This is all about counting the number of sides on the shape. And it is a pentagon. And the next shape, is this a rectangle, a rhombus, or a square? Now, as we've just discussed with the previous slide, a square and a rhombus have all 4 sides equal in length, and this doesn't, so we can safely say this is a rectangle. A scalene triangle, an isosceles triangle, or an equilateral triangle. To help you, because it's not too clear from the picture, all 3 sides are different lengths in this triangle. So it can't be equilateral because the sides would be the same length. If it was isosceles, 2 sides would be the same length, so it must be a scalene triangle. Okay, another easy one here, trapezium, triangle, or square. Another easy one, triangle, heptagon, or pentagon. And again, this is about counting the sides. So tri means 3, tricycle, triceratops. So triplets, we can safely say this is a triangle. And here you have a choice. Again, it's about counting the sides of the shape. Pentagon, heptagon, decagon. If you count carefully, the shape has 10 sides, which makes it a decagon. Well done for completing the quiz. Slightly different maths today. We're going to be having a look at 2D shape in art. And this artist here, Wassily Kandinsky, was known for his geometric style of art. Now, geometric art is art that has mathematical shapes in it. So if we look at this painting here, we can clearly see some of the shapes that you've been looking at this week. So you've got circles and semicircles. We've got 2 triangles here. That looks like a scalene one. We've got a right angled triangle there maybe. Definitely a pentagon over here. We've also got some straight lines. So the artist chose to use the geometric shapes, and then he's overlapped the geometric shapes, which has made some other lovely shapes. So here we have a circle overlapped by the triangle, so we get an unusual shape there. The 2 lines that overlap here provide us with a little quadrilateral there. These remind me of the barcodes that you find on foods. And again we have a reflect here. We've got half black, half white circle. Google have made a really clever animation of this particular piece of art. No, abstract art. It doesn't particularly show something we can recognise. And it shows how layering of the lines and the different shapes have created that layered effect. I think it also shows clearly how using colour in certain places can emphasise the shape. Got a 3 by 3 square there. These circles being highlighted in different colours have brought them out. The purple overlapping the blue has made a darker blue there. We've got part of a circle reflected here. See how it's still effective, but not as much without the colour in it. This artwork by Kandinsky is called Black and Violet, and I think if you look carefully, I'm beginning to see objects in here. To my mind, but I might be wrong, these look like boats, and this almost looks like a face. It reminds me a little bit of the Picasso faces that you collaged and drew right at the beginning of the autumn term. Once again, you can see how all of these 2D shapes have been overlapped. So by overlapping a triangle, the black shape here has now become green, and it really emphasises the shape of that isosceles triangle. So, your activity today is to produce your own geometric artwork using 2D shapes, lines and colour. Should be a really fun activity. I look forward to seeing your creations. And obviously if you need circles at home, you can use a cup, or you could use a tin. Squares, again, you could use boxes, or you could draw your own very carefully. I know it's difficult without a protractor, but see what shapes you might have at home that you could perhaps draw around. And remember, for these straight lines, find yourself a ruler. I will put these slides on Google Classroom in case you want to look through them again. Good luck.